Hello everyone. Welcome to the 17th meetup of Kaggle Days Meetup Delhi NCR. This is our 10th virtual meetup. So if we talk about 2020, then it has been a really challenging year for everyone. But even in these tough times, our community it has not ceased to grow because we've conducted till now 10 virtual meetups and 7 data catch-up sessions. And also we've hosted some really amazing speakers in these months. So it has been really a prosperous year for us because even our LinkedIn page it currently has now more than 3,200 followers. So yeah, even in these tough times, it was really a great year for our community. So this is the last meetup of this year. So we have with us today Crislanio Macedo. He's a Kaggle notebooks master and a dataset and discussions expert, and he's currently working with a retail startup. So the agenda for today. Crislanio will be talking about applying factor analysis with clusters and labels semi-supervised learning approach in classification problems. Uh, and from 8:45 after his talk, we'll have a Q&A session. So yeah, over to you now.
Hi everyone, can you share my screen? That's okay.
Yeah, we're good to go now.
Okay. Thanks for the invitation. Hello everyone. I'm glad to present at Kaggle Days Meetup, and today I will talk about applying factor analysis with cluster and label semi-supervised learning approach in classification problems. At the end in the presentation, I hope to have motivated the use of factor analysis through this simple hands-on that I will be presented. This is this is be a brief meetup, and I will talk about some concepts of semi-supervised learning, factor analysis, and hands-on of factor analysis. I will present a simple case of Hintail using clustering, factor analysis, and classification modeling, and I will talk about basic concepts, explain some concepts of factor analysis, applications, and at the end I will show a case. I will talk about an unsupervised problem, and we will define a target in the data set through clustering, and then we will apply algorithms for classification and apply factor analysis to understand the clusters. So, but who am I? I'm Crislanio Macedo, or just Cris. I'm from Brazil. I have more than 3 years of experience with data science. I'm worked as a data scientist for a large multinational at Instituto Atlântico, Ceará, Brazil, working on projects related to application performance monitoring. And I'm currently a data scientist at a retail and startup, Iso Varejo Inteligente, working on measuring results and analyzing KPIs. And I'm Kaggle Notebook Master. I have a degree in Computer Science for Federal University of Ceará. And that's all. I'm highly interested in machine learning application, especially in anomaly detection, anti-line detection, fraud detection. So, but what is semi-supervised learning? So semi-supervised learning uses the unlabeled data to gain more understanding of the population structure in general. So It's a class of machine learning tasks and techniques that also make use of unlabeled data to train, and typically a small amount of the labeled data with a large amount of unlabeled data. In the figure, you can see two classic type of learning, unsupervised learning, and you have a mix of both. In case of in semi-supervised learning approach, we create a target and then transform the unsupervised learning into a supervised problem. For our problem, we use the cluster approach to define a target for the groups created. But in this case, I will in the figure you have an example of clusters group. But what is clustering? In this case, clustering it's a task of dividing the population or data points into a number of groups such, such that data points in the same group are more similar to other data points in the same group and dissimilar to the data points in the other groups. It's basically a collection of objects on the basis of similarity and dissimilarity between them. So through clustering, we apply factor analysis to interpret each cluster, and we will classify the data in each cluster. In this case, you have inter-cluster distances are maximized and inter-cluster distance are maximized. Now we will talk about a little bit about factor analysis. And in this case, this guy Charles Spiemann, it's a pioneer of factor analysis in connection with study human intelligence. This theory that disparate cognitive test score reflect in a single generous factor lead to development factor analysis. And factor analysis is using data from Charles Spiemann paper General Intelligence. So it's used for a different in different contents. Factor analysis, it's a interesting technique that I show for you. Basically, we need to talk about some concepts of text and factor analysis. And factor analysis, it's used to understand the line dimensions or factors that explain the correlation among a set of variables, and to identify a new, smaller set of uncorrelated variables to replace the original set of correlated variables. So factor analysis, it's a class of procedures used for data reduction and summarization, and it's a interdependence technique, the distinction between dependent and independent variables. We have some advantage and disadvantage. For example, one advantage is that can with can factor analysis can identify latent dimensions or constructions that directed analysis may not. And an example of disadvantage is that giving factor name that they require knowledge of theory because seemingly dissimilar attributes can correlate strongly for results. Um, but why factor analysis? So I will use factor analysis to interpret clusters in the data. Um, in this case, factor analysis can explain covariation among multiple observed variables by mapping variables to latent constructions that is called factors, and to understand the structure underlying a set of measures, gain insight into dimensions, and construct validation. We have a lot of applications. This is some example, for example, in physical and biology and science, geochemistry, hydrochemistry, ecology, molecular biology, and etc. So an example in gradual quality management, it's important to relate the spatial distribution of different chemical parameters to different possible sources which have different chemical signatures. So, for example, a sulfide mine is likely to be associated with high levels of acidity dissolved sulfite in transposed metals. These signatories can be identified as factories through factor analysis, and the location of possible source can be suggested by contouring the factor scores. This is another example. Factor analysis can be used for summarizing high-density short DNA or RNA molecules and market segmentation, personality and cognition, and physiology, etc. So, talking a little about theory, one common factor model has this specification model where we have the factor F is not observed, only OH1, OH2, and 3 are observed. So this is a simple model of factor analysis. And we have some statistics associated with factor analysis. For example, commonality. Commonality it's a concept that represents amount of variance or a variable shares with all the other variables. And it's a proportion of variable explained by the common factors. The age value represents the total variance explained by each factor. We have a factor loading. It's a correlation between the variables in the factors. Factor matrix. It contains the factor loads of all the variables on all the factors. And the factor scores are composite scores estimated for each correspondent of derived factors. And in the KMO, it's a measure of sampling adequacy. It's used to examine the appropriateness of factor analysis. In this case, KMO, if you have high values between 0.5 and 1, indicate appropriateness. Values below 0.5 imply not. We have Bartas test of disparities, and this is another measure of adequacy. You have a correlation matrix. It has a screen plot that it's using to plot eigenvalue against the number of factor in order of extraction. So this is one common factor model interpretation. For example, the commonality is the percentage of variance of AGI explained by F. This is a simple model that explains what factor analysis is. And this is a matrix notation. For example, the factor pattern matrix has columns that represent derived factors, and the rows represent input variables. Loadings represent degree to which each of the variables correlated with all the factors. And it has a loadings range from -1 to 1, and in high loadings provide mini interpretation of factors. So after this, I will we have some tasks for this meetup. This is a retail case. So suppose that you are responsible for the analysis that will serve as a foundation for the strategy of entering the Brazilian market of a large multinational retail in the supermarket section. You have two tasks. First one, classify Brazilian municipalities based on the available information. In the test two, develop a classification model to calculate the probability that a given municipality is below to one of the group created. So we try to, at the end of the case, to explain the follow question: which groups of municipalities should be the gateway to accompany the country and why? So I will classify Brazilian municipalities in groups and interpret this group created. To do this, we need first transform the unsupervised problem into a supervised problem, and we will create it clusters, then a simple model to classify municipalities, and we use factor analysis to interpret latent variables. So let's go. These, these are the factor analysis steps. So at the end of the general pipeline, you have this factor scores, okay? And the factor scores can be used to understanding new entries in the data or understanding cluster, understanding the data set. So first we need to have the problem formulation. Afterward, the construction of the correlator matrix. We have a method of factor analysis. It's a hard test to determination of number of factors, and you need to choose some rotation methods for factors, and then you need to interpret a step of interpretation of factors. So this is a factor analysis pipeline. And now I will show the notebook that will follow this general pipeline. I described it earlier. So this is a step that we need to follow. First, we need to label data with cluster approach, and we will apply a simple model classification, and then we use factor analysis to interpret the clusters, interpret the data. So this is a Kaggle notebook. I will share at the end of presentation. This is our case. This is our two tests that you need to solve. First, you need to import the libs, and I will use the factor analysis library. This is an interesting library. You can see here has a lot of rotation methods, has a example. It's an interesting library. So I use this library to apply factor analysis approach. And now this dataset it's from Ibope Inteligência, and we have a lot of 5,000 Brazilian municipalities. We have some interesting variables. So um, look that we have a demographic density, we have life expectancy of birth, we have Gini index that's mean also known as the Gini coefficient. It's a mathematical instrument used to measure the social inequality of a given country, federality, or unity, or municipality in our case. You have latency rate, you have a lot of interesting variables in this data set. You'll need to see the pattern of these variables and extract factors and interpret with these factors or clusters. So in this case, for example, um, intensity of poverty, it's a interesting variable. That's mean that's identify the poor are those who live in the extreme poverty. So I import this data set. I translate these variables because it was in Portuguese and I put in English. So this case, it's a simple exploration in the data. There has no missing data in this variable. Um, and in this case, it's an analysis. Check how many duplicate values per columns. This is a head of data. So in this case, you have uh, some variables and you have the municipalities. So you try to put in these municipalities in clusters and try to understand each clusters. So in this case, it's applied factor analysis. We have some steps. This is a problem formulation. We need to classify Brazilian municipalities based on on the available information, this information, and we need to try to develop a classification model to calculate the probability that a given municipality belongs to one of the group creators. So you need to apply cluster and apply classification model to try um, understand the groups in the probability of a new interest. You need to construct self correlation matrix, and that's all. This is a fact analysis. This is another interesting picture. In this case, um, if you have this is a observed variables. So fact analysis in this case try to understand the correlations between these variables. In this case, the name of this factor is food quality that represent the correlation, the relationship between these variables of the factory. So um, we will use the factor analysis in order to identify factor latent factors. And we use these factors to identify the most significant clusters for the multinational retail in our case, okay? So now I will apply the correlation. Correlation, it's interesting to apply. So this is some results. We have we have a common pattern between this variable. Correlation is not causality. In this case, you have mortality to 1 year. It has a high correlation with life expectancy, but of course it's expected that. Um, so this is another graph. You see the correlation between municipalities. So this is some example. If you have a correlation using some municipality, in this case São Paulo, it has high correlation with other municipality. Now, for applying factor analysis, we need to follow some steps. In this case, it's necessary to apply adequacy test. In this case, we apply the KMO, and for now results, we had a good result. So all data, it's appropriate is to use factor analysis. So these values indicate that you can proceed with your planning factor analysis. The other tasks is to choosing the number of factors. This is a hard task, but in this case, I use Kaiser criterion and screen plot. Both are based on agent values. So determination based on agent values, only factors with agent values greater than 1 are retained. So in this case, we have 4 agent values greater than 1. So this means that we have 4 factors. So this is a plot. This is the same result. We have four factors in our case. Now performing factor analysis. Now this is another step of factor analysis technique. You need to choose a rotation. In this case, it's most commonly rotation technique, Verimax. But you have another rotation methods. In this case, this is a simple example of rotation, and we choose Verimax that maximize invariance of squared loads. This is a simple interpretation of each factor results. So if you has a result of for the loading less than or equal 0.5, this means that's low. If you has the results more than 0.76, this is a good result. Um, I apply some colors in the results. This is all factor analysis results, guys. You have these variables, and for each factors. In this case, we have eight eight variables in the factor 0. In the factor 1, you have 9 variables. In the factor named 2, you have 2. In the factor 3, you have just one variable. So um, I, you just consider a logic cutoff of 0.5 you'll be using here. In this case, this cutoff determines which variables belong to which factor. So in this case, this is now our results. This is an example of commonalities that says it's a proportion of variability of if variables that explained by the factors. So that means that, for example, index of indigency um, has a proportion of variability in the entire data around 0.5. This is a graph. Now you just to put you need to interpretation each cluster and try to plot the graph of factor analysis. So for the factor 0 has 8 variables with values above 0.5. Factor 1 has 9 latent variables. Factor 2 has just 2. And it's a hard work rename the factory. So this is the most um, variables with high coefficient in the factor 0. I renamed this factor most populated municipalities by adult mostly. The factor 1, this is the variables in this factor. Um, in this case, we have 9 variables. This factors meaning developed municipalities. The factor 3, this means less developed municipalities has these 2 variables with high values. Um, in this case, and this is the factor 3. In this case, this factor it's like this factor tells us which municipality is less developing. And for example, a factor 0 and factor 1 indicator would be using. It's good factor for now case. Um, this is a plot with the results. With this is a factor 1. This is a factor factor 0. This is a factor 1, factor 2, factor 3, and this is a task 1. You need to classify municipality based on the available information. So as you need to apply clustering, and and in the result of cluster, it's a group with the municipality. So I apply Camins. Camins it's a good and supervised learning approach algorithm. It's a type of supervised learning. It's used for when you have unlabeled data. This is not our case. And Camins it's used to find groups with had not been explicitly labeled in the data. So I apply Camins, and you need to choose the right key. In this case, the our final results is that we have four clusters. So this is our clusters, but consider that this is interesting because you have 2 clusters with just one element, and this is a simple case, guys. So in our case, we I dropped these clusters with just one element. So um, this is our clusters, and now we need to apply classification of a classification algorithms to classify municipalities in the clusters. This is an interpretation of each cluster, an example. For example, this is a mean, the standard variation, and for the cluster 0, income per capita for the cluster 0 and cluster 2. We have a difference mean and standard variation. And now we need to apply a classification model to try um, classify the municipality and clusters. So this is a, a simple example of classification algorithm. Um, in this case, I apply some algorithms. You have a results, and you have some false positive, false negative, but you have a good result for each algorithm. And at the end, we need to interpret interpretation of clusters. Um, so this is top 10 municipality of the clusters with the best municipal human development index by literacy rate. So you see that each cluster has high values for these two variables. But look that um, you it's interesting that you can use just these two or other variables to interpret each cluster, but it's necessary to understand the relationship between all variables. So um, factor analysis it's a good technique to understand this relationship between all variables. So this is a scatter plot with cluster 0, cluster 1. In this case, we have another example. In this case, top 10 municipality of clusters with the best municipal human developed by income per capita. This is another um, plot example. But uh, now it's more interesting that if you use the scores of factor analysis to understand these clusters. So um, the factor analysis is estimated uh, is estimated in this case, and you need to create the scores of factor analysis. So you have four clusters. This is a clusters. Factor zero is most popular in municipalities by adult. Mostly, these two factors is more important for us in our case. So now I compute the factor score for each factory, factor one, factor two, and apply in each cluster. So this is a step of calculation of factor analysis score. And at the end, this is a highest scores of factor analysis for the factor zero per cluster. So this is an example. This means that this municipality has high scores in cluster zero. In cluster one, this municipality has high score for um, cluster one, and I follow the steps. This is a highest score of factor one municipalities developed by clusters. So I compute the score for factor one and apply to cluster zero and cluster one. This is our results. And this is case of factor two. This is um, highest scores of factor two. So this is a municipality with high scores of factor two. And um, so that's it, guys. You have a final report, and in this case, the main question: which groups of municipalities should be the gateway to accompany the country and why? In this case, you can use the factors to understand the pattern in the data. You can use the scores to choose which municipality it's good or not. In this case, the factor one, the factor zero, factor one, it's good for us. And in this case, factor two, okay, that is less development municipality, it's not good for no case. So this is our good choice. For example, these municipalities is it's a good for no case. So guys, um, that's it. I hope I have motivated the use of factor analysis and which can be used in the interpretation of data. And summarization, in our case, we had an unsupervised problem. We transform into a simple supervised problem, and we are using factor analysis to assist in making to choose a municipality for the retail company. This is some references. Um, and we have some references. This is slide are on my GitHub and Kaggle, and this is thanks in advance to everyone to the opportunity.
All right, so that was a really informative and intuitive talk. So let's see if we have any questions on the live chat. I don't think we have any questions as of now. So if anyone has any question about this topic or anything in general, they can just ask it right now. So we have a question here. Can factor analysis be applied to categorical data?
Yeah, yeah, yeah. In this case, as you need to use to transform your data, and then you can apply factor analysis. Factor analysis is similar to PCA, but in this case, the interpretation is different. It's a simple method that then you can use with a lot of type of data. Um,
All right. Uh, do you want to add anything?
in this case, we have another question. Can you tell us
Yeah, yeah.
if you can go from unsupervised for supervised? In this case, it's a simple approach. All data has not labeled, but we have a lot of variables, and we transpose the data set to build the label. So we build we use the k-means, and you build clusters. So the label is the clusters. If you have 10 clusters, you have 10 class. So afterward, use this 10, 10 classes to try classify a new municipality in a new clusters. And the proposal factor analysis is to understand the clusters to help to interpretation of each clusters. Suppose that you have interesting clusters than another. So this is our approach. This is a simple approach. Um, you has a lot of interesting variables in this data set.
So yeah, I guess that answers that question really well. So another question we have here is that how factor analysis can help in making model inferencing better in a real world setup.
I think that factor analysis can be used to using together with other methods. So math methods. So um, you have a lot of example in retail case and customer segmentation. You need to understand the correlation, the relationship between variables. So I think that you can use factor analysis to understand the relationship between variables. If you have more than 1,000 variables, it's interesting that you try to create factories for these variables. You understand these factories. It's a technique for to to help to help us, but you can use with others techniques.
All right. So another question that we have here is um, like how can you share your experience regarding factor analysis as it can be a part of major part of an interview. So any experience or thoughts you want to share regarding that?
Um, I use factor analysis a long time, and um, I try to understand the the one moment.
Sure.
Um, Now I'm trying to understand the details of retail case, but I not much experiences using factor analysis. It's interesting that you have two types of factor analysis. In this case, I show you exploratory factor analysis, but has another confirmatory factor analysis. In case of confirmatory factor analysis, you use the created factors to understand the data. But I not apply. I'm trying to understand more this technique to apply real world problem, and it's interesting. I learn a lot, and a library that I show you, it's very interesting. Um, I recommend it. I will share this notebook with this presentation for you guys.
Okay, great, great. So one person is asking if we can share the link. Yeah, we'll
Yeah,
share the Kaggle link, Kaggle notebook link, and the presentation after the session.
yeah.
So I don't think we have any more questions here. So we can wrap up this now. So thank you very much for such an amazing session. And for those who are watching, they can subscribe to our channel and also follow us on LinkedIn to get updates about all the events that we have coming up. I guess we have another question here on YouTube. Which advantages give factor analysis over usual dimensionality reduction techniques?
This is interesting question. In case of fact analysis, you use to understand the not not exactly dimension of um, of the data, but you understand the variables in the data. If you use PCA in our case, you need a components, and in case of factor analysis, you you have factors. So it's a little different, but um, the most advantage is to understand the factors in the better way. So the scores of each factors can be used for understanding the factory, the relationship between the variables.
Okay, great. I guess they got their answer. So, yeah, we can wrap up this session now. Thank
Yeah.
you for being here with us.
Thanks.
Okay, then goodbye, everyone.
Thanks, guys.